Welcome to Hope Academy. My name is Mr. O, and today I'm going to be discussing specifically a concept called long division. So I'm going to be focusing around a concept called long division, which helps me sort of understand how to work with different polynomials and when I'm dividing them. And so I'm just going to be focusing on the concept specifically long division. If you are looking for synthetic division, I do plan to make another video based around that concept, but for today is specifically around long division. And so when I'm doing long division, a lot of times it will come in a different format. So sometimes you may look at a question and you'll see it sort of in this format where it's like, let's say x cubed plus, I'm making it up right here, 5x squared plus 4x plus 3 divided by, let's say, x plus 2. Sometimes the format will look like this. There are other times where on the same problem, and this is exactly the same thing, it might look like this. 5x squared plus 4x plus 3 divided by x plus 2. And it will look sometimes like this, but when we are doing long division, the formal process when we are trying to either divide this or this, which is exactly the same problem, but when I am trying to do these type of questions, this is actually how I need to set it up. Usually what I'm going to do is I'm going to take what we call the numerator, right here, the numerator, which means the top part of the fraction. I will take the numerator and I'm going to actually copy it down real quick. So 5x squared plus 4x plus 3. And I'm going to divide it. And usually this division symbol is also represented by this little sort of like square root sort of looking thing, but it's not a square root. And what's going to happen is I'm going to put on the other side my denominator, or aka the lower part of this fraction right here, the x plus 2. And that's how I set it up, just for purposes of getting ready to solve this. Afterwards, this is how the long division works. Every time I'm working through this, my goal is to cancel out the front numbers that exist, or whatever is left, I will be trying to cancel out the front numbers. So for example, when I'm trying to get to x cubed, I need to think about what x times what number am I going to plug into here will equal to x cubed. And so when thinking in this relationship, I'm thinking, well, x times what equals to x cubed. And so if you think about x squared, well, x times x squared is going to be x cubed. So I know the fact these are going to cancel out eventually. And so to continue on, based on the distributive property, what's going to happen is that it goes here to here. Well, I'm going to also do it here to here. So 2 times x squared is going to be plus 2x squared. And what happens in the long division property is that it's always based around canceling. And so that means that when I put the negative, this negative is actually distributed to both parts here and here. So literally this will be x cubed minus x cubed, and which I know is going to cancel out because x cubed minus x cubed is going to be 0. But then what happens is that when I do 5x squared minus 2x squared, so 5x squared minus, because a negative and a positive will be a negative, so 5x squared minus 2x squared will be 3x squared. Afterwards, all of these values that I have right here will be carried down very simply. So I'll just copy down exactly what I have left. But the part is that after I do this, I'm literally going to be doing the exact same process I just did here, but I'm going to do it down here and continue on my division process. And so what I mean by that is that now I need to think about x times what value that I'm going to add now into multiply together is going to equal to 3x squared. So if you think about it and you're like, okay, well, I need to cancel out 3x squared. I need to make sure it's going to be x times 3x. That's my goal. So 3x times x will be 3x squared. So let me repeat that. X times 3x equals to 3x squared. I do want to emphasize that one of the misconceptions that I have seen from my students is the fact that sometimes they're trying to automatically cancel it by making this negative 3x squared. But remember that in the property of long division, all of these values are going to have a minus sign next to it when I'm putting these values in. And so I want to make it the exact same value as the front value. So 3x squared. So, but to continue, I still have 2 times 3x, which is going to be 6x. And so I'm going to do that, put a negative in front, and then continue on. So 3x squared minus 3x squared is going to cancel out. But 4x minus, this is going to be 6x. So 4x minus 6x is going to be negative 2x. And then bring this down again. Because I did not touch the 3, nothing happened to it, so I carry it down. Okay. And to continue on to the last part, so I need to, as I mentioned before, cancel out the front number. It has to be exact same value I'm going to get on the bottom. So I want to get to negative 2x. So I think x times what value will equal to negative 2x? Well, if I plug in negative 2, x times negative 2 is going to be negative 2x, which is what I want. And the continued distributive, 2 times negative 2 will be negative 4. And then I'm going to put a negative sign here. And these are going to cancel out again. But here, be careful because 3 minus negative 4. So minus negative, when I multiply these together, will be positive. So it will be 3 plus 4, which is going to be 7. To provide the final answer, but before I do so, I actually need to mention that this 7 is going to represent what we call the remainder. It's the leftover residue or leftover things that exist. Be aware that sometimes there will not be a remainder, depends on the question, and this might end up being 0. But that being stated, make sure you understand that if it is not a 0, you have a remainder then. And so to conclude my computation for this question, I need to put out the final answer. And so I'm going to copy this part down right here, which is going to be the x squared plus 3x minus 2. And then plus, now I'm going to put the 7 over the fraction. So it will be x plus 2. And to box this up, and this is my final answer for this question. And so be aware that sometimes it might not look like in this format. I have seen old formats before, and I do want to mention it just in case this helps. But sometimes the question might actually show you the answer like this. Okay, and so what this means is that x squared plus 3x minus 2 remainder, which is the R7. But this is an old format that I do not think I've seen in textbooks recently. Most of the times these days they expect you to answer in this format, so be familiar with this type of format. But to continue on, sometimes long division is not as clean as this. Sometimes maybe there's a remainder and such, but sometimes it is actually more simple or something where you're going to have to understand how to work through it. And I'm going to provide another example real quick on this topic. So for example, let's say that it wasn't as clean as that. Let's say that I'm making up a new question. Let's say that you're given this question, x5 minus 5 over x minus 1. I wanted to make that up. And I told you to do a long division process for this question. And so to set it up, as usual, I'm going to set it up in that format that I did last time, where I have this sort of square root looking thing, but it's not a square root, it's the division symbol, like this. And this is what's going to happen. As usual, as I mentioned before, the first thing we need to do is to cancel out this front number in order to simplify and eventually get to the answer. And so I need to think this times what value equals to x to the 5th. If you think about it a little bit, it's going to be x to the 4th. So because x times x to the 4th, it will be x to the 5th. And to continue the procedure as I was doing before, it will be negative 1 times x to the 4th, which is negative x to the 4th. But be careful when I'm doing this, because what happens if you are solving this out, you realize that x5 minus x5 will cancel out. But if you notice, there is no like term or similar term to the x to the 4th. So what's going to happen is that you're going to first deal with these negatives, which is going to make it positive, and you're going to actually bring it down. So it'll be x to the 4th, and I'm going to bring that negative 5 down. It's going to come down. So it'll be minus 5, like this. And I'm going to have to keep going like this. So to cancel out x to the 4th, I'm going to plug in x to the cube. X times x to the cubed would be x to the 4th. Negative 1 times x to the cubed is negative x cubed. Do the same process. Realize that I'm going to take this out. There's no term like that above that has an x cubed in it. So it'll be negative your negative x cubed, which is positive x cubed, minus 5. Same thing again. I got to keep going, doing the same process, because x times x squared would be x cubed times negative 1 times x squared, which is negative x squared. Do the same process, and it's going to take some time, and there are other processes that do exist to speed this up, but it is one of the processes. In my opinion, long division lets you ensure that you don't make any silly mistakes, because the other method, in my opinion, is more efficient, but it could be a lot of potential for you to make a silly mistake. And so just to continue with the computation, I need to keep going until I get a remainder in which I cannot simplify that out. So x times x will be x squared. Negative 1 times x will be negative x. And to continue, same thing again. So I'm going to do that. This will become positive. So it'll be x minus 5. And I can still simplify it one more time. And I'm going to do plus 1. So x times 1 is x. Negative 1 times 1 is negative 1 minus that. And it's going to be positive 1. So it'll be negative 5 plus 1, which is negative 4. Okay? And so after going through this whole process, and I'll move it up, you have to realize that there's no necessity for us to actually go through this whole process all the time, but be aware this is how long division works. So after the long division is done and whatever not, I need to make sure to, of course, write down the final answer as usual. So it's going to be this answer. So I'm going to write it down here as the answer. x4 plus x cubed plus x squared plus x plus 1. And remember, the remainder is -4, so it'll be minus 4 over x minus 1. So I'm taking the denominator value like these ones and I'm plugging it here, and this will be my final answer. And so be aware that when I'm doing long division and working through these type of questions, it is going to happen where sometimes the values are going to, look sort of like this, where it's very scaffolded. Sometimes it's not going to happen like that, but be aware that we are always looking at the front values to cancel them out, and we prioritize doing that every single time. Also note that I cannot simplify -4 afterwards, because if I try to do x times something else on top, there's no value that I can multiply x with to make it just -4. So that's why when I get to this point where there's no x value, or I can't simplify it more than a certain value that it reaches, it's going to end up being the remainder that's left over. And so that concludes my explanation around long division. Thank you so much for watching this video. Please do subscribe to our YouTube page or like our Facebook page so that we could continue to provide you content like this. I hope you have a wonderful day.